right here is arguably the most important equation for waves, so understanding this is crucial. Light travels forward left to right along the axis of propagation, and it does this at a constant speed of 2.998 times 10 to the 8 meters per second. Thus, propagation speed and the speed of light are the exact same thing. Simultaneously, each individual point along the length of the wave merely oscillates up and down. For this reason, we can measure wave propagation as a function of distance. With that, let's pick this point z on the wave. We then identify the next point with the same height and the same slope. In this case, they both have 0 or flat slopes. What we've just mapped out is the wavelength, the horizontal distance separation of a wave cycle. From this perspective, wavelength is the distance required for a wave to repeat itself. But propagation speed, or any speed, is not just about distance, but it's also about time. Here we are mapping point z over discrete snapshots in time. We still have distance on the x-axis, but we're showing how the distance of a wave propagates as a function of time, where when we increase time, we also increase distance as the wave propagates further. We also see that our point of interest, z, stays put horizontally and simply oscillates up and down. Eventually, it repeats itself, completing a full cycle. This is called a period, and it's a change in time from when we get from the same position and the same slope. It's represented as a change in time because it is a change in time. Importantly, in this very same time duration, the wave travels forward an entire wavelength distance. Let's put this all together. Light's propagation is by definition happening at the speed of light. And the speed of light, or any speed, is distance over time. We witnessed in the snapshot diagram that for one cycle of the wave, the distance traveled is wavelength and the time elapsed is a period. Therefore, c is equal to lambda over period, or propagation speed is wavelength divided by period. Or simply, c is equal to lambda frequency, because frequency and period are inverses of each other. This is a way we can summarize everything together from an equation standpoint.